Our lesson today is on proving lines parallel. We'll learn about applying angle pair measures to algebraic expressions, proving angle pairs congruent or supplementary, and proving why angle pairs are congruent or lines are parallel in a two-column proof. First, we'll look at two theorems. Theorem 3.11 says, if two lines are parallel to the same line, they are parallel to each other. This is similar to what you would have learned in algebra as what's called transitive property, which said if A equals B and B equals C, then A equals C. Instead, we don't have such a property for parallel lines, so we use the theorem. Theorem 3.12 or 3.12 says, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Here's a picture. Here's an example. Perpendicular lines, both perpendicular to A in this case, make M parallel to line N. Example, are lines P and Q parallel? Why or why not? Identify an angle pair. For example, this total is 120 degrees. These two angles then would be corresponding angles. And we know that corresponding angles are congruent. So that would be our answer. In the next example, we'll solve the equation. To solve it, we identified these two angles. Once again, we know that these two angles are corresponding angles. We know corresponding angles are congruent or equal. So we set 2x plus 10 equal to 120 and solve for x. I'll subtract 10 from both sides. 2x equals 110, divide by 2, so x equals 55. In the next example, 4x and 2x are consecutive interior angles, which we know are supplementary. Take 4x plus 2x, supplementary again means add them and set them equal to 180 degrees. So I add the two angles, set them equal to 180. In this case, we simply solve for x. 6x equals 180 degrees. Divide both sides by 6. So x equals 30. In our next example, the two angles listed are alternate interior angles. We know that these are also congruent or equal, so we set the two angles equal to each other. If the angles are congruent or equal, we set the two angles equal. If the two angles are supplementary, we add them and set them equal to 180 degrees. We first identify the angle pair and then look at if they're congruent or equal. Solve for x. I'll subtract 2x from both sides, and I will add 5 to the left since I'm bringing the x's to the right. So 6 equals x. And our next example, we have alternate interior angles, which are congruent or equal once again, as we know, so we set them equal to each other. Subtract 3x from both sides. So 2x equals 20. Divide both sides by 2. X equals 10. Next, we'll take a look at two-column proofs. We have a two-column proof. Our first column is statements, our second column is reasons. where we're going to prove our angle pairs congruent or lines parallel. In our first example, we're going to prove angle 4 is congruent to 7. That means that we're going to be proving that angle 4 and 7, which are alternate interior angles, are congruent. We start with our given information. So our first statement is simply restating what's given. A is parallel to B. Our reason is it's given. We're proving alternate interior angles congruent by an example. So we can use everything except that in our proof. Start with the angle that you're proving congruent, which is the first one, which is 4. Pick another angle that 4 is congruent to. In this case, my choices are 8 or 5. So I'm going to use 5. 4 and 5 are vertical angles, so we have vertical angles congruent. I'm going to be abbreviated for the angles and congruent symbol. Whatever angle I pick, in this case angle 5, it's congruent to automatically angle 7, the other angle in your proof statement. 5 and 7 are corresponding angles, so we have corresponding angles congruent. And now we're going to say if 4 is congruent to 5 and 5 is congruent to 7, then angle 4 is congruent to 7. And we have a property from algebra we use, it's called the transitive property of congruence. And that's it for the first one. So let's take a look at the other example on this page. We're going to prove angle 1 is congruent to angle 2, so we're going to prove corresponding angles congruent. Start again with the given information. A is parallel to B is given. Pick an angle other than 2 that angle 1 is congruent to in the problem. So we have some choices again. Angle 1 is congruent to 3, or angle 1 is congruent to 6. I'll use angle 1 congruent to angle 6. Angle 1 and 6 are alternate interior angles. Our reason then is alternate interior angles are congruent. Again, I'll abbreviate for these to make room. Angle 6, my angle I chose, automatically will be congruent to the other angle, which is 2. Those are vertical angles congruent. And then our last step again is if angle 1 is congruent to 6 and 6 is congruent to 2, angle 1 is congruent to 2, and this one is always going to be transitive property. In our next example, we're proving angle 9 is congruent to angle 8. Looking along the same transversal line, we can see that 9 and 8 are alternate exterior angles. First statement is given. A is parallel to B, C is parallel to D. That's given. We start with angle 9. Pick a different angle other than 8 that it's congruent to, because remember, we're proving the angle pair is congruent. By example, that would be angle 2 or angle 16. I'll use angle 2. 9 and 2 are corresponding angles, so corresponding angles congruent is my reason. Angle 2 is congruent to angle 8. Those are vertical angles. Again, we always start with the angle in the proof statement, 9, and then we end with the other angle, 8. Notice again on this one that by transitive property, 9 is congruent to 8. In the next example, we're proving A is parallel to B. Start with the two pieces of given information. C is parallel to D, and angle 1 is congruent to angle 4. That's given. Since C is parallel to D, look where angle 1 is on the other lines. So if you can notice, angle 1 is on A. And A is on our top piece up here, where C is parallel to D. So pick an angle that 1 is congruent to. If you choose over in the other section from the one that 1 is in over here, it just makes it a little bit shorter proof. So my choices are 1 and 5, which are corresponding. You can use 1 and 13, which are alternate exterior angles. I'll use 1 and 13, so 1 is congruent to 13. Those are alternate exterior angles congruent. Since 4 is congruent to 1 and 1 is congruent to 13, in our next step already, because we were given one angle pair congruent in the given information, we can say that angle 4 is congruent to angle 13 by transitive property. Now if you notice, in our last step, we're showing or proving that A is parallel to B. So our proof statement is always the last statement, as you've noticed in each proof. And in this case, look at what are 4 and 13. Now we switched over to C. 4 and 13 are corresponding angles. So we have, if corresponding angles are congruent, then the lines are parallel. In our last example, we're going to prove CA is parallel to ED. Start with the given information. Angle 2 and angle 6 are supplementary. That's given. So our reason is always given. In our first statement, we restate the given information. Our first reason is always given in a two-column proof. Pick two other angles supplementary. That would be angle 4 and 6. So we'll first say they're a linear pair. Identify what they are. And that's definition of a linear pair. Then we can say we know that linear pairs are supplementary. Angle 4 and angle 6 are supplementary. And our reason is what we just said. Well, we know linear pairs are supplementary. If we have two angles that are supplementary to the same angle, 2 and 6 and 4 and 6 are both supplementary, as you notice, to angle 6 in this case. So 2 and 4 would be congruent to each other. And we give a name to this. It's called the congruent supplements theorem. Again, theorems are just rules. And this just tells us that we can say they're congruent. And our last step, angle 2 and angle 4 are corresponding angles, so we know that the lines are parallel. So I'll write down my proof statement, and my reason is if corresponding angles are congruent, lines are parallel. And that's it for today.